Remeshing is generally understood as the process of reconstructing any input geometry while satisfying certain topological requirements, like a specific amount of output polygons or surface details. At the same time, the reconstructed geometry must either match or closely approximate the input geometry. Additional texture data like normal maps can be generated in the process that can be used to authentically replicate the shading of the geometry, even when going from multiple millions of polygons down to a few thousand. Remeshing is a powerful technique that allows artists to retarget any kind of input geometry or discover new workflows as to how 3D assets can be created. But there are several reasons why remeshing has not been adopted as a standard workflow for 3D productions. The first reason is that the remeshing process can easily run for hours or even days and can require extreme amounts of memory. The second reason is that remeshing can only be used if the input mesh meets specific topological requirements. For instance, a clean topology without any degenerate polygons, or even more problematic, the geometry must be fully watertight, which is rarely the case for actual production assets. With InstaLOD, these problems have finally been solved, and remeshing is now an accessible tool for every artist. In this video, we're going to look at how to get started with InstaLOD's Remesher in a variety of different scenarios. In later videos, we're going to look at some other workflows like scan processing, as well as real-time ready kit bashing. Let's go ahead and get started. All right, so here we are in InstaLOD Studio, and the first thing I want to do is go and create a new profile. And I'm going to go ahead and select Remesh and then click Create Profile. So next up, I'm going to go ahead and bring in a mesh here. So I'm just going to go off to my second screen here and grab a mesh. And I'm going to go ahead and bring in this troll character. So as you can see here, we have this troll and it's got about 127,000 polygons. I can show you the wireframe here for the body. We can also see that this troll is made up of multiple submeshes here. And you can see there's different UV layouts for some different materials. So if I just go to the material tab, we can see we have 3 different materials for this troll, resulting in 6 draw calls for this character. So now what I'd like to do is I'd like to lower the polygon count of this troll, but heavily optimize it for a real-time environment like a game. And so that's going to involve things like combining all these objects together, merging materials, and definitely lowering down this polygon count for some LODs. And that's exactly what the Remesher does here. You can see that we have the Remesher here off to the side. I'll just go ahead and hide the UV viewer for now. And so the Remesher, what it's going to do is it's going to reconstruct the input geometry here. And it's only going to reconstruct the new mesh with the amount of polygons necessary. And by default, what the Remesher will also do is combine all of our objects in the scene into one. It's going to remesh them and merge them together. And this is really going to help with reducing our draw call count. And then what it's going to do is it's going to unwrap the UVs of the newly reconstructed mesh, providing us with some efficient UV shells. And then finally, it's going to bake and transfer all of the texture information that we have here. And it's going to transfer them onto the new mesh. It's even going to do things like taking all of the high poly information here from this troll and baking it into a new normal map as well, all the high frequency information. So I'm going to go to my remesh settings here, and I'm going to change this under remesh settings. I'm going to go to maximum triangles, and I don't want this troll to be any larger than 5,000 polygons. So I'll type in 5,000 here, and let's go ahead and adjust some of the texture settings. So I'll go to the texture output tab here, and this is where we can define things like the resolution of the generated textures that we're going to be baking. So let's go ahead and keep this on 2K for now. And we can also choose things like the export format. But there's one thing I wanted to mention here, which is about the normal map. So what's really cool about the normal map here is, when you have 16-bit textures like normals, what we can do is we can actually do an 8-bit dithered here, an 8-bit dithered option. And so if you choose the 8-bit dithered option, what that's going to allow you to do is lower the bit depth of a normal map, have it where it's less heavy in file size, but you're not going to get that common stepping effect that you might get from going from a 16-bit normal map to an 8-bit. It's a fantastic way to be able to lower the file size and the resources needed to be able to load up the mesh and its heavy normal map textures. In this case, I'm just going to go ahead and leave this all by default. But I also wanted to bring your attention down to this texture pages section. These are the texture maps that are going to be generated for the reconstruction. So in this case, I'm going to go ahead and create an object-based normal map. We can also bake some ambient occlusion here as well. And I want to call your attention to this custom textures option here. And so what this does is it takes, you see we have a base color map here. We also have a normal map as well. So if I go ahead and look at this, why don't I go ahead and just open up the UV viewer here so we can see it. So if I go ahead and select something like the troll and then click on this icon here to view the textures, we can go ahead and look at the normal map here. So you can see we have the veins and the different high frequency details of this troll. Because we have this information in our original mesh, in our scene, what we can do is make sure that we enable this custom textures option, and that's just going to transfer all of the previous texture information onto the newly reconstructed model. So if we go back here and I take a look at the resolution, I did mention that I have set this to 2K. But what's also interesting is you can see that we have super sampling here in the texture pages section as well. And so what this is going to do is it's actually going to multiply our chosen resolution here by a certain factor, in this case by 2. So what InstaLOD is going to do behind the scenes is it's going to bake out a 4K texture map behind the scenes, and then it's going to sample it down to 2K. So we get all that nice detail from a 4K texture bake, but it now samples it down into a much more lightweight 2K resolution texture map. And if we wanted to, start texturing the model once we've reconstructed it, we can also bake some really useful maps, such as the position, the curvature, the thickness, all that kind of stuff that we can use. So we could texture this in something like Instamat if we wanted to. So now that I've got all my settings set up, let's go ahead and hit start to begin the remeshing process. So again, InstaLOD is going to reconstruct a brand new model from scratch here in the form of this troll. It's going to unwrap the UVs of that reconstruction, and it's going to bake and transfer all of that texture information from the original and put it on the reconstructed mesh. And it's actually doing something really powerful behind the scenes here as well, in addition to all of that, which is it's actually baking 2 normal maps. So the first normal map is going to be that normal low to high poly bake. But the second is that it's going to take that original tangent space normal map that we just looked at on our troll, and then it's going to convert that tangent space from the original to the new mesh. You can see that it just reconstructed and combine both of those normal maps together. And you can see it's a very seamless process, which means that, all the details from the normal map on the original troll are going to transfer over to this newly reconstructed mesh, which you can see it's now done. So this is the newly reconstructed mesh that InstaLOD has created here. We can see it's done a fantastic job here creating this new reconstruction. You can see it's exactly 5,000 polygons. So if I go ahead and click on it here, you can now see, it's modeled over all the details like the face and the teeth. You can see it's even combined the objects here. You can see here in the outliner that it's merged over and combined the cloth with the body, things like that. Really nice looking result here, and you can see it just took a matter of seconds. Let's also take a look at those textures. So I'll go ahead and bring back that UV viewer. You can see this is the newly constructed UVs and textures. We get these nice big shells. Again, this is for the entire object here on our 2K texture here. Let's also take a look at that normal map as well. So you can see we've generated an object space normal map. In this case, converted it from a tangent space normal map, but it's included all those extra details like the veins, the teeth, all that stuff, very seamlessly combined into one texture map here for the normals. And of course, we also baked an ambient occlusion map as well. Now, there's another thing that I wanted to mention here that the Remesher has done for us, and that involves taking a look at the back of this troll. So I'm going to go to the top here and I'm going to go back in time. We've got this timeline across the top, which allows us to go back to a previous step in the process when working with InstaLOD. And we can see here that on the back of this troll, we've got some broken geometry along the back. And that might be a problem for some remeshers, but in this case, you can see for InstaLOD, it was no problem at all. Because if I go to the reconstruction, you can see what it's done here is it's just modeled over the back of the troll to create a nice, clean result. So you can see the remesher has done a fantastic job with this mesh. So with one click of a button, you can see that we've taken a troll that had multiple pieces on it, multiple materials, and 127,000 polygons, and it's remeshed it to combine all of our objects together, merge all of our textures, and drop our draw call count to 1 with a total poly count of 5,000 polygons. But one of the powerful aspects of InstaLOD is the ability to create a workflow that can be used to process large amounts of data with thousands of assets of all shapes and sizes. And in this particular case, what we did was we set a hard limit, as you can see here, of 5,000 polygons for the maximum triangle count. And that applies to any asset that we process. But how do I know if I need more or less polygons when I process large amounts of data? Up next, what I'd like to show you is how we can create a scalable asset processing workflow, which will allow us to remesh any model and always make sure that we have as many or as little polygons as we need. So to do that, instead of using the maximum triangles here, I'm going to change this to the fuzzy face count target. The fuzzy face count target automatically determines how many polygons the reconstruction needs based on this level of quality that we specify here. So you can think of as normal as pretty good for up close and for real-time destinations. Then if you go to low, or lowest, that can be optimized for LODs that are more distant from the camera, or you need to crunch down some more of that polygon count or get a more simplified mesh. And then for high or highest, this can be really helpful for offline rendering. You can do some really nice reconstructions for offline renders and get beautiful detail while also being able to optimize any polygons that are really unnecessary for that particular destination. Now, another parameter that I want to talk about is the surface construction resolution. And you can see it has a drop down very similar to the fuzzy face count target. And so the surface construction resolution tells InstaLOD how much information should be modeled out into the geometry versus how much should be put into that normal map. Again, here's the normal map that we had. In this case, it was an object space normal map, but you can see that we've modeled out those details into the textures instead of the actual geometry itself. So what we could do is we could lower or raise the resolution to determine how much InstaLOD's going to model. So if I set this to something like lower lowest, then the model is going to be much more simplified and more of that high frequency detailed information is going to go into that normal map. Or if I increase the resolution to high or highest, or very high, sorry, or extreme, then it's going to model out more details into that geometry that it reconstructs. Keep in mind that higher resolutions will increase the processing time during remeshing. So in this case for this troll, what I'm going to do is I'm going to set the fuzzy face count target down to something like lowest. I really want to crunch down this troll to get a really high LOD. And I'm also going to set the resolution down to low as well to get more simplified geometry as a result. And let's go ahead and see what it does here. So let's go back. I'll actually click unmodified here so we can see what the original troll looks like. And I'll just delete my timeline history. We could have also just pressed start right away, but let's just go ahead and do that now. Again, InstaLOD's going to reprocess this model, create a new reconstruction, unwrap the UVs, and bake those mesh maps. And take a look at this. This is my really far and distant LOD model. I probably never see it any closer than something like this. But we're now down to just over 1,000 polygons for this reconstruction. You can see this, the wireframe, because I set this down to something like low for the resolution, it's created much more simplistic geometry. But you can see it's baked all those high poly details, even the veins from the previous tangent space normal map into this new reconstruction. It looks absolutely stunning. And then again, we can see here on the back, all those details are really nicely preserved and it's continued to close the back of the troll. So let's go ahead and take a look at what the Remesher does if I set this to a few different settings. So let's go and reset this to a resolution of normal and a fuzzy face count target of normal. These are actually the default settings for the Remesher. So when you choose the Remesher as the mesh operation in InstaLOD Studio, by default, you're going to have a normal face count target and a normal resolution. And let's go ahead and reprocess this. And so you can see I can just hit start here instead of going back in the timeline. I can just go and say, let's reprocess the unmodified mesh, the one that we get directly on import. And very quickly here, we're going to get our remeshed result with our settings set to normal. And so again, you can see a beautiful reconstruction here. This is a brand new model that InstaLOD has constructed, and it's now about 14,500 polygons. Really stunning results here. You can see that seamless blend between the different meshes that were in the scene, the sub meshes for the cloth. And again, 14,500 polygons down from the original model here, which was almost 128,000. So another stunning result from the Remesher. And what was great was that I didn't have to tell InstaLOD how many polygons I needed to get this level of quality. It determined how many polygons I needed by using the fuzzy face count target set to normal. So now what I'd like to show you is how this is a truly scalable workflow by using the Remesher, because now I'm going to change the mesh that we're processing in InstaLOD. So again, I'm going to go over to my second screen here, and let's bring in a hard surface model this time. So I'm going to go ahead and drag this in. And so here you can see we have this communicator model. It's about 156,000 polygons with a lot of different pieces here, a lot of different sub meshes. You can see we've got these different parts here. There's a really complex piece here for this top section. You can see that the antenna has separate parts. There's even parts on the inside here, which we can see through. So it's a very complex piece, model here. And we can take a look at the UVs. I'll just go ahead and show them here. So for the model, you can see we have a bunch of different parts here, all nicely laid out. And you can also see that we have multiple materials as well. So if I go to the material editor, you can see we have a lot of materials here. We even have one for the screen, which you can see here. This is an 8K texture just for the screen, but you can see it's only using this small portion of the texture space. And that's a lot of wasted space, and especially when it comes to file size for all those texture maps. So we're definitely going to need to combine all these pieces together. We definitely need to merge those materials as well, so we can reduce the draw call count and we can lower the polygon count here. And we can do all of that with the Remesher. So let's go ahead and I'm not going to change any of the settings here. I'm just going to go ahead and hit start. We're using the same settings that we had set up for that initial troll mesh. And again, InstaLOD's going to reprocess this geometry, create a brand new version of this communicator from scratch, unwrap the UVs and bake mesh maps, and take a look at this gorgeous result from the Remesher. Absolutely stunning. It's now one model. See, it's connected all these pieces here. Remember the complex model that we had here at the top? This is all one piece still, but you can see a beautiful reconstruction with much more simplified geometry here. You see for that texture information there. The antenna is now one piece as well. And take a look what it did over here as well. You can see we're even seeing through the mesh, and it's modeled over this complex piece here in the back, which is great. Again, now this is one model, which means with one material resulting in one draw call. So we can go ahead and take a look at those materials. I can use the filter and just click on this, and you can see that we have one material for this entire model. And if I bring up the UVs, you can see what it's done here. It's actually used an organic algorithm to be able to process this. So you can see it's kind of been laid out in a more organic shape. But what we could do actually is we can go over to the mesh operation settings here, and I can change the way that the UVs are done here. I could say, let's change this to something like, hard surface axial. And because the Remesher is so fast, I can go ahead and hit start and just, reprocess the model. And it's going to remesh the model, but this time giving me more like what I would expect when working with a hard surface object for my UVs. And so now if I click on the model, you can see here, they have much bigger shells divided up for all the different pieces of this communicator. And again, you can see this screen is now fitting alongside, packed in with all those other materials as well. So it's a much more efficient use of texture space. So now what I'm going to do, I'm just going to go back and change this to auto again. But what I want to show you is how we can create a chain of LODs using the Remesher. I want to create maybe 4 or 3 different LODs with one profile here in InstaLOD Studio, taking advantage of the Remesher. So let's go ahead and do that. So what I'll do first off is let's go ahead and just rename this to LOD0. LOD0 is going to be our input mesh and no optimization is going to occur here. So I'm going to go and I'm going to choose optimize here in this case and just tell it to, give me 100% of the original triangle count. Basically, that means we're not going to do any optimization at all for LOD0. Then I'm going to add an entry. We'll call this LOD1, and we'll go back to the Remesher. And I'm going to go ahead and set this to a fuzzy face count target of high, because I still can get away with a few more polygons here. And I'm going to leave the resolution for the surface construction set to normal. Then for LOD2, let's just go ahead and we'll use the Remesher again. And this time I'm going to change the fuzzy face count target to normal, so just the default settings. Then for LOD3, we'll go ahead and lower this again. This time I'll use low. So really the only thing that's changing here is the fuzzy face count target for the Remesher, and it's going to determine how many polygons it needs for each of these reconstructions. It's still going to combine all of the meshes, and it's also going to merge all of the materials. So let's go ahead and hit start and see what it does. I'll use the unmodified mesh. Again, that's the high poly source mesh. So it's actually going to create 3 reconstructions here, and it's going to do it very quickly. And there you can see it's now finished processing all of those LODs, and you can see we have these tabs here up at the top. And so what's really nice here is I can go ahead and hover over these tabs and we get a live preview of our LOD here in the viewport. And you can see the polygon count just dropping as we continue to go. Even at LOD3, you can see that this looks really nice, even up close, which is incredible. But really an LOD3 like this would probably only be seen from, pretty far away, if not really far away. But even up close, you can see this is absolutely stunning. You can see it's modeled over, the connections between the screen and these parts here. It's done a beautiful job with these side parts. Again, with the top as well. Just almost 3,000 polygons here from the original, which was 156,000. So a fantastic job by the Remesher. So we were able to generate all 3 of these or 4 of these LODs here very quickly using one profile in InstaLOD. And this is scalable, right? This is scalable because InstaLOD is determining how many polygons it needs using the fuzzy face count target. So just to prove that one more time, I'm going to go ahead and bring back the troll. We'll go ahead and import that. And let's use this profile that we just created, this recipe of creating these LODs on a completely different asset, and hit start. And create 3 different reconstructions of this character using those settings. And so there we go, very quickly. I can just go ahead and hover over these different LODs. You can see even at LOD3, right? A beautiful result. And I can use this one profile here to now process a whole bunch of other assets. So if I wanted to save this profile, for example, what I could do is just go to the File menu and then choose to save this profile. And then I could load this up in InstaLOD Studio if I wanted to as a template and just continue to process other meshes. Or what I could do is I can go to the File menu and choose to run this in InstaLOD Pipeline. And so what InstaLOD Pipeline allows us to do is take the profile that we have loaded up in InstaLOD Studio and now batch process a large amount of data. I can just add tons of files and folders here into the InstaLOD Pipeline dialog, or you could use the command line version of InstaLOD if you prefer something like that. Provide an output path, set up some naming conventions with some variables, and then just hit start, and InstaLOD will automatically create all the LODs that I need using this profile here in InstaLOD Studio and utilizing the Remesher for all of that data. So as you can see, the Remesher is a fantastic way to optimize your 3D models by doing the automatic retopology of an asset, combining meshes, and merging materials to reduce draw calls. And with the fuzzy face count target, you can see that you can easily create this scalable workflow to create LODs for large amounts of data. Thank you very much for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.